This is lesson 5.2, and we're going to talk about medians and altitudes of triangles in this lesson. So medians are made by connecting the midpoints of a side with the vertex opposite. So let's go ahead and add that off to the side here. The median point of the intersection forms the centroid of the triangle. And this point is 2/3 the length from the vertex to the midpoint of the opposite side of the triangle. So centroid is that point where they're meeting. Then we'll get into altitude, which is perpendicular to a side, and it's going to form the orthocenter, but we'll talk about that in just a little bit. So centroid, one thing that is kind of easiest to do is to, if it gives you the entire length there, to divide it by 3 to kind of figure out what this little segment is, because that's going to be 1/3, and then we just double it to find this segment here, which is going to be the 2/3. So if we look at here, this is CM. I always say label what information they give you, in your picture. So if this is 8, then the segment that it kind of continues on, HM here, we're going to just double the smaller one to get HC right there, or CH. So doubling 8 times 2 means this is going to be 16. So then this one, 16 and 8, can't really see that very well. Let's get rid of that. So if this is 16 and this is 8, together it adds up to make HM, which 16 plus 8 is a total of 24. All right, so let's try another one. Over here we have P is the centroid, and centroid is actually kind of like what you could balance it on, the center of gravity. So this point right here, if you kind of put it on the tip of your pencil and it kind of looked like a paper airplane, but balanced it right here at this point, it would balance and be that center of gravity. So YV, the whole length here, is 12. So I always say divide it by 3, and that's going to give you the smaller little segment here, which would be 4. So PV is 4, and that means that YP is just double, take your 4 and double it, and that's 8, and yep, 4 and 8 makes 12, which is what the total was. So go ahead and try this one. Label all your pieces, and then figure out, so if CG here is 6, and GF here is 2, and FB is 7. Go ahead and figure out what those 3 pieces are, and then check when you're ready. So hopefully this time you took, for GE, you cut 6 in half, because this is the smaller segment on CE. So this would be double GE. So that means GE would be 3. Then we know that this is the smaller segment here, which is 2, so we're going to double it to get AG. And then centroid is created by using the midpoint here. So with a median in the middle. And so if this is 7, then this has to be 7, and we can also see that kind of by the tick marks, but it's not always marked with tick marks. All right, flipping over here, we're going to look at it in a coordinate plane. And there's kind of a trick to it here. There is either the segments finding the midpoint and then connecting, drawing the lines opposite to kind of its vertex here. And then seeing where it meets. Or you can use the formula. So these are the midpoints. These are the vertex points of our triangle. And so that's what we're going to use for our formula. So this would be our x1, this would be our x2, this would be our x3. This is our y1, y2, and y3. Basically, you're just finding the average. You're adding them all up and dividing by 3. So for our x's, we have a 2, we have an 8, and we have a 6. And for our y's, we have a 3, a 5, and a 1. So we're going to add all those up. 2 and 8 makes 10, plus 6 is 16. 3 and 5 is 8, plus 1 is 9. And then we're going to divide them by 3, kind of reduce it. So 16 divided by 3 is 5 1/3, or 5.33333. And then 9 divided by 3 is 3. So there is our centroid, and it is right there, as you can see. So go ahead and try this one on your own. Here's our coordinates here, those 3. You can either draw from the midpoints, or you can use our formula as we showed up above. So whichever method you want to try, go ahead and do that. So here's our formula. If you did it over here and you're like, but I don't really know what that point is, it's not on a cross section. Remember, it's the distance here divided by 3. So 1, 2, 3, 4. 4 divided by 3, that's going to give you this distance here, which is 4 divided by 3 is 1 1/3. So this distance is 1 1/3. So that means we're at 1, 2, 3, and then add 1 1/3. So we're at 4 1/3. So it's a little bit easier just to kind of use the formula, but it's totally up to you. So orthocenter is what we're going to move to next, and it's the last triangle. There's 4. And this one's created by finding the altitude. Altitude, remember, is the height, so perpendicular to the base up to the vertex point. So from each vertex point, we're perpendicular to the opposite side. So those are our altitudes points, and that's the orthocenter. Okay. So what we're going to do for this one is we need to find out what these slopes are so we can get a perpendicular slope and then draw our perpendicular lines. So for our slope for JH, I go up 1 and over 3, 4, 5, 6, so 1/6. So perpendicular, I'm going to flip it, 6 over 1, and I'm going to make it negative. JI, we're going down 1, 2, 3, 4, and over 2, which is really just going down 2 over 1. So negative 2 over 1, which flips and changes to positive. And then IH, so I'm going to go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Up 5 over 4, and then we're going to flip it, 4 over 5, and make it negative. So now I'm going to go from the opposite, so opposite of JH here is the vertex I. So I'm going to go from I, and I'm going to go with a slope of negative 6 over 1, which I'm actually going to change it to 6 over negative 1. So I'm going to go up 1, 2, 3, 4, 5, 6, and over negative 1. It's still a slope of negative 6, but that way it stays on the graph here. So then I'm going to draw my line. And this is perpendicular. Make sure you're using a straight edge. I just don't have one on here. And then we are going to go from H, and we're going to go 1/2. So H, down 1, or sorry, up 1 over 2. And then we draw our line. So that line looks like this. And that is perpendicular. And then going from J, the last one, J, down 4, 1, 2, 3, 4, over 5. And then we're going to draw our line from J to that point there. And here is our point where they touch. And we're not going to find the coordinates, we're just going to graph. So, orthocenter. Where is the orthocenter located on triangle ABC? Is it inside, outside, or on? Well, if it's an acute, it is inside, as we can see here. If it is a right, all of them meet right there at the right angle, so it is on. And then if it is obtuse, we're all the way out here, so we are outside. So we have talked about 4 different concurrencies in triangles here. So you kind of need to come up with a way to help you remember these. So circumcenters, perpendicular bisectors. So just kind of here, think about what is a way that you can remember and kind of connect these names to the way that they are drawn on the triangle.